Hello everyone. For better use of our controller in the farm, we have created a relatively simple video tutorial for environmental controllers. Part 1. Equipment installation and debugging. These are the precautions and requirements for installing wiring. Before installing the wiring, you need carefully check it to avoid problems caused by wiring or interference in a later stage. Next, let's take a look at the interface on the environmental controller. This is the motherboard of the environment controller, used for human-computer interaction. This area is used for inserting SIM cards. Inserting a data card or SIM card can achieve controller data networking. When the controller triggers an alarm, it can make foreign calls and send text messages to on-site users. This is the RJ45 Ethernet port, used to achieve wired networking of controller. This is the USB interface, which used to insert a USB flash drive to achieve local upgrade control program and parameter import and export. The following diagram shows the port identification of sensors and relay devices. It provides interface wiring guidance for convenient on-site installation and debugging. Next, we will introduce the control motherboard at the bottom. There are 3 sets of interfaces on the right side of the control board. The first group is an IEC 220V power interface that provides main power to the environmental controller. The input voltage range is 85 volts to 305V. The third group is the DC 1-to-V backup power interface, which provides backup power to the environmental controller. The primary and backup power supplies can seamlessly switch and provide power off alarm function. The second group is the IEC 0803 expansion box interface, which is used to provide DC 240V power supply and S485 communication to the expansion box. IEC 0803 is used to expand the wiring ports of relays and sensors for the 1680 controller. The lower right part is the relay interface of the control device. This area port is used to connect the on-off signal lines of equipment such as fans, cooling pad, heaters, etc. And it supports voltage not exceeding 250 volts and to a current connection. The lower left part is the sensor device interface. These ports are used to connect devices such as temperature, humidity, pressure, carbon dioxide, and ammonia. The analog output, D input, and 485 rupees interface are also located in this area. The upper left area is the expansion module interface. After connecting different expansion modules, provide additional sensor interfaces and alarm input interfaces. Next, we will demonstrate how to wire the environmental controller. Firstly, we connect the AC 220V main power supply and DC 1-to-V backup power supply. There are markings on the terminal indicating the neutral wire, live wire, positive and negative poles. Connect according to the identification. Next is the IEC 0803 expansion box interface. Connect C1 to C4 according to the wiring method shown in the diagram. The wiring of the relay can be connected according to the schematic diagram on the sticker. There are 18 relays here. The first 16 relays are used to connect control equipment. Generally, the switch of equipment is controlled by controlling the on-off of the live wire. The first 2 relays can be selected as normally open or normally closed according to the wiring. The other relay types can only be normally open. The last 2 relays are used to connect the alarm horn and battery detection, respectively. The wiring method for battery detection can refer to this wiring diagram. The lower left area of the motherboard is used for connecting sensors, alarm inputs, and 0 to 10 volts analog outputs. Let's start wiring. Firstly, the wiring of the 0 to 10 volts sensor. There are a total of 6 groups. 12 volts and 0 volts are common terminals, and 0 to 10V is the signal terminal. These ports are used for connecting ammonia sensor and the potential feedback signal line of the push rod motor. Now, we connect the potential feedback signal lines of 4 sets actuator here. Next is the 4 to 20 mA sensor interface. There are a total of 4 groups. You can connect pressure sensors and carbon dioxide sensors. Here, 24 volts and 0 volts are common terminals, and 4 to 20 mA is the signal terminal. We connected the carbon dioxide sensor in the first group. Connect the wires to ports 49, 50, and 51 in the order of red, white, and black. Shielding layer grounded. Connect the pressure sensor to the second group. The red and black lines are connected to ports 53 and 52, respectively. Attention! On the pressure gauge, the hose connected to the plus should be installed outdoors, and the hose connected to the minus should be installed indoors. Waterproof and dustproof measures need to be taken for pressure pipe openings both indoors and outdoors. Next, connect the temperature sensor. There are a total of 10 sets of temperature sensor ports. Temp and COM are grouped. No need to distinguish between positive and negative electrodes. We connect 10 sets of temperature probes. Here, shielding layer grounding. Then we connect the humidity. 12 volts and 0 volts are common ports. Wilhelm is the signal port. There are 2 groups in total. Now we connect 1 humidity. Connect 45, 46, and 47 in the order of red, white, and black. Shielding layer grounding. Then connect the wiring for the 0 to 1 OV analog output. AO is the positive terminal. COM is the common terminal. There are a total of 6 groups, generally used for connecting variable frequency fans or dimmers. We connect 4 groups here. Next is the RS485 interface. The A-B lines of 485 communication devices can be connected in parallel. Here, port 35 is A, 36 is B. Attention! When connecting multiple 485 devices, the address cannot be the same. Here, we connect a 485 electricity meter. Next is the pulse input interface. There are a total of 6 groups, usually used for connecting water meters. Pulse and COM are grouped, connecting wires without distinguishing between positive and negative poles. We connect to water meters here. Finally, there is the alarm input, which is used to monitor the external alarm of the controller. Total are 6 groups. DIG and COM are in 1 group, can be connected regardless of positive and negative poles. Attention! The signal line connected here must not be live. Now, we connect the alarm signal line to the first group. After connect all wires to controller, then user can power it. Next, we configure the device just connected. Power on and enter the system. The controller is not configured with any devices, so it is reporting average temperature failure. This is a normal phenomenon. We can turn off the alarm first, and then start configuring the device just connected. Click the menu key to enter the menu interface. You can see that there are 4 functional interfaces at the bottom of the interface. Parameter, history, install, manage. The function of configuring devices can be found in the install interface. The devices connected to the controller are divided into 2 categories. One type is sensing equipment, such as temperature, humidity, CO2, etc. Another type is power control equipment, such as fans, cooling pad, air intakes, etc. Now, we start configuring from sensing devices. You can see that there are 10 sets of temperature sensor channels on the right, corresponding to 10 temperature sensor interfaces. Other sensor channels also correspond to the wiring ports on the motherboard. Now, let's start configuring the device that just connected. Firstly, there is the 0 to 10 voltage sensor. We just connected 4 sets of potentiometers. Here we configure 4 sets of potentiometers. The number of potentiometers will generate it automatically. Next is the 4 to 20 mA channel. We just connected CO2 in the first group. The second group is connected a pressure sensor. We also configure it here. Next is the temperature sensor channel. We just connected 10 temperature sensors. We also configure 10 sets of temperatures here. If the temperature sensor is installed outside the house, need to be configured as outside temperature. Next is the humidity sensor channel. Configure a humidity sensor. After configuration, return to the install interface. Click on temperature definition to enter this interface. Select which temperature sensors as the data for the average temperature. We associate the 9 inside temperature sensors here. Then return to the main interface. You can see that the main interface has already displayed the sensor data we just configured. The temperature data represents the average data of 9 temperature sensors. Press the number key 1 to view the current measurement value of each sensor. Continue to enter the sensing interface and configure other devices. The 2 water meters we just connected need to be configured on the pulse input interface. And the S485 electric meter in bus input interface. It should be noted that the meter model we are connected to is DTM830. So the device model needs to be changed to DTM830. The address and baud rate of the electricity meter also need to be consistent with the controller. The baud rate of the controller is 9600. And the default address for this meter is 2. So it is necessary to check whether the baud rate and address of the electricity meter are consistent with the controller. You can check it in the following way. First, press and hold the Set button for 5 seconds to enter the password verification interface. Click button U to enter password 1. Click the Set button again to enter the settings interface. The ID of the device address, which is currently 2 and consistent with the controller. Click button U to switch. C2 refers to the ratio of current transformers, which needs to be input according to the actual installed current transformer. Baud is the baud rate, currently 9600, which is consistent with the controller. Then click the P key to return. Next, we will start configuring the relay equipment. Enter the relay setting interface of the control device. You can see that there are a total of 16 relay configuration channels, corresponding to 16 relay interfaces, respectively. Can be configured as a fan, cooling pad, light, fogger, etc. We configure according to the actual connected devices. Because it is an operational demonstration, so we configured some common relay devices. 9 sets of tunnel fans. One set of heat. 2 sets of cooling pad. And 2 sets of air intake. Next is the configuration of analog output. Analog output equipment can be configured as variable frequency. Fans, dimmers, digital air intakes, variable frequency heat, etc. We have connected for groups and also configured some common analog output devices here. There are 1 set of dimmers and 3 sets of digital air intakes, respectively. After configuration is complete, return to the device test interface. Test whether the relay device and analog output device that were just connected are under normal control. Blue represents the device in operation, gray represents the device in a stop state. Manually turn on and off each device to ensure that it is under normal control. Analog output interface, input different voltages. 0 to 10 voltage corresponds to 0% to 100% opening angle. After confirming that all devices can be controlled normally, return to the install interface. Enter the fan setting interface and configure the actual air volume values for each set of fans. This interface can also set the rotation function. When the required air volume of the house is low or in the minimum ventilation mode, different fans can be designed to rotate and operate to avoid uneven ventilation in the house. The prompt on the left also briefly explains the operation mode of this function. Priority indicates that the opening sequence of fan units of the same type and air volume can be set. Next, set the air inlet parameters and click on Inlet Settings to enter. The air inlet parameters include Parameter Setting, Installation Setting, and This Setting. In the Parameter Configuration interface, it is necessary to input the area and wind speed of each group of air inlet. By using these two parameters, the maximum air intake volume of the air inlet can be determined. Priority and tunnel priority refer to setting the opening priority of different air inlets in non-tunnel mode and tunnel mode. Priority is divided into T high-low, T0. Tunnel priority is divided into off, high, and low. Different levels of air intakes are explained in the prompt box on the left. Automatic calibration and calibration time can set whether to perform automatic calibration every day and the time for automatic calibration. Attention, the air inlet controlled by a potentiometer will not automatically calibrate. Next is the parameter settings for the install setting interface of the air inlet. According to the control method of the air inlet, it is necessary to set the air inlet switch time or switch voltage. The air inlet controlled by a potentiometer requires setting the full open and full close voltage of the air inlet, and the air inlet should be associated with the corresponding potentiometer. The intake port without a potentiometer needs to be set with a fully open and fully closed time for the intake port. The de-icing function is that when the outside temperature is too low, the air inlet will move once every cycle to prevent the air inlet from freezing. After setting the inlet parameters, return to the temperature definition interface. According to the installation positions of the heater and temperature sensor, associate the temperature probe with the corresponding heater. If multiple temperature probes are associated, the average value will be used for judgment. The air inlet can also be associated with temperature probes in the corresponding area. If there is a large temperature difference between different areas of the house, the air inlet will automatically adjust the opening size to reduce the temperature difference in the house. Next, enter the size setting interface. On this interface, it is necessary to set the size of the house to determine its cross-sectional area. The controller will calculate the maximum wind speed that the house can reach based on the total tunnel airflow and the cross-sectional area of the house. Next is the configuration of alarm parameters. You can set high and low temperature alarm values for the controller, high or low water consumption alarm values, high gas concentration alarm values, etc. You can also set up functions such as testing alarm and battery detection. Finally, let's return to the main interface and learn about the icon display. The device status bar displays the current operating status of the device. Blue indicates that the device is running. Gray indicates that the device is turned off. The Control Details column displays the current age, target temperature, current ventilation mode, and current ventilation volume, etc. The number of fans on the wall at the end of the house represents the number of tunnel fans that were just configured. Loongk press the fan icon for 3 seconds to enter the fan layout interface. Through configuration, it can display according to the actual layout of the fan. Return to the main interface. The number below the air inlet indicates the current opening ratio of the air inlet. Loongk press any air inlet icon to enter the air inlet position configuration interface. You can modify the position display of the intake port on the main interface. Click on the icon for the average temperature. Can display the average temperature of each area. Then there is an explanation of the functional shortcut keys. Press the number key 1 to view the values of each sensor. Press the number key 2 to view the operating status of each control device. Press the number key 3 to view the usage of water, electricity, feed, and gas for the day. Press the number key 4 to view the daily feed and discharge statistics of each feed tower. Press the number key 5 to view the daily production data of the current batch. Press the number key 6 to view the current control details. For example, the fully open temperature of the fan, the on/off temperature of heating, wet curtains, and other equipment. Press the number key 7 to display the D-input alarm content and alarm type. Press the number key 9 to view the device network code and current version. Press the number key 0 to enter data, such as mortality and cold number, egg production, egg weight, etc. Press the plus keys to switch languages. Click the point key to enter the setup wizard, which is used to configure the basic parameters of the controller. After all the parameter settings of the controller are completed, the parameter copying function of the controller can be used. Inserting a USB drive, click on Export. Can quickly copy the parameters of the controller. The above is an introduction to the wiring, configuration, and interface of the controller. Thanks for watching.